Hey, hello everyone. Uh, Hopefully it's obvious which one is Grace and which one is Xin here. So I'm a research scientist at Uniswap Labs, and
I'm a data scientist at Uniswap Labs.
yeah. So today I think it's a timely occurrence where Uniswap we just started this competition to mine the address to deploy V4 on. And so very soon we'll have data flowing through various pipelines, including that one at Dune, where you can query Uniswap events and make analytics about it. So we thought today we should kind of introduce different ways you can look at V4 contracts. And I think in order to talk about V4, we have to give you some context as to where you should use as a stepping off point. So with that, the way we're going to run the session today is I'm going to talk about the easy stuff, and I'll leave the hard stuff to Grace. So I'll give you an overview as to what has been developing from V1 to V3, and then what's the difference, what's the delta between V3 and V4. And then Grace will specifically talk about the way you can look at on-chain data and how you can parse out different information, so to speak, about V4 pools and hooks and so on. So one motivational point I want to make is if you look at the top chart, so that's roughly, think of it as like market share of Uniswap protocols. And as soon as V3 launches, it quickly becomes very relevant to any people who's looking at data. And it stayed relevant till this day. And I think one point that made V3 different from previous versions is it's very flexible. It allows a lot of new ways of making markets to come in and compete. And I think one of the big innovation of V4 is it's even more flexible, and it allows people to express their I guess, preference as liquidity providers even more precisely. And so I personally expect V4 to be also very competitive and very relevant for people looking at data. And there are some, on the other side, there's stability through time. If you look at, for example, TVL by pool and token pairs, you can see that there is always a power law distribution. So some of the charts you make will stay relevant as well. Okay, so let me quickly talk about the design and architecture principles of V4 and how they're different from V3 specifically. So there is a singleton design, meaning the entire V4 will be one smart contract. And all you have to do is kind of understanding the inner workings of it. There will be hooks, and these are, quoting myself, you can think of them as V3 pools with custom APIs that are calling out to external contracts. So that allows you to do a bunch of things, including time-weighted AMM, limit orders, custom oracles, and a lot of other things that are still being worked on. It allows dynamic fees. So in V3, there's 4, maybe not more now, but there's used to be 4 fixed fee tiers that you can choose at deployment, and you can't change it afterwards. Whereas now, for any pool, you can update your fee structure while the pool is kind of working. We now support native ETH. In the past, every time you swap ETH, we actually do a wrapping and unwrapping for you. Now you can just do ETH in the pool. There's custom accounting, there's flash accounting, those things I'm not going to get into today. I'll just focus on the top 3 parts. All right, so if you want to understand V4, it's very helpful to understand V3 because that is the departure point on which we built V4. So the structure of V3, okay, so let me re-emphasize. In V4, if you don't use any of the customization that we allow, you will get a V3 pool. So that is why I say understanding V3 is important. So a V4 pool that has none of the hook flags turned on, that doesn't have custom accounting or dynamic fee, will be a V3 pool. So the V3 pool works like this. There is a factory contract. Every time you create a new pool, there's a create pool event that's shown in the black boxes. That event will generate a particular smart contract. That smart contract is then immutable, so you can't change any of the parameters of it, including its fee tier, its token pairs, and its addresses, and so on. So every time you create a new pool, there will be a new smart contract. And going forward, when you create liquidity positions or you make a swap, that new smart contract will emit a new event. So there's mint, burn, collect, swap. And the way you sort of combine Uniswap v3 events into an index table is you will collect all these events from all different smart contracts, and you will link them by connecting them from the create pool event out of the v3 factory contract. And then you can then sort of index them however you want. In v4, the pools are virtual, so they're no longer identified by their smart contract address. Instead, they're now identified by this pool key thing. So every pool will be in the pool manager, which is sort of the v4 contract. And every time you create a new pool, there will be an initialize event, which you can then somehow find a pool key, which I guess Grace might talk about it. But anyways, the pool key is how you identify pools in Uniswap v4. And then each pool may or may not have a hook that's attached to it. Hooks are external contracts that can be called by when you execute particular pieces of code within Uniswap v4, and then they have the ability to call back into the Uniswap v4 contract. And then once you have the pool initialized, you will be able to do things like modify liquidity or swap. Did I miss anything?
No, I think the only other thing that I would add is that in v3, these initialize is pool or create pool, which happens in the factory, and modify liquidity and swap are both technically part of the actual pool contracts themselves. And so that differentiation doesn't happen in v4. They all are within this one pool manager contract.
Okay, sweet. I think that is all from me.
Okay, so now we're going to segue into looking at v4 data. And one beautiful thing about Dune is the fact that they are going to have wonderful tables that are easy to query. So some of this information is going to be actually even easier to access than what's shown here. But v4 is not live on mainnet yet, and so we have some tables that we can show, but the actual data itself is not quite in a ready state to show you some nice charts. So today we're going to start with pool initializations, and this essentially, it's just showing kind of the differentiation between a v3 pool create and what a v4 pool initialization will look like. So that pool address that Xin was referencing in v3 is essentially going to turn into this pool ID, and you'll see it just kind of looks like a weird hash. It does have a meaning. Since it's a unique identifier, it essentially is a combination of those 5 things that will differentiate each individual pool on v4. So a couple other cool pieces of information here that are new to v4. You'll notice the hook address. Obviously, this is just a test pool, so there is no address there. It's just the null address. But when we have v4 pools live, you'll see an address there. And then you'll notice the fee. And I'm pointing this out only because it is similar to v3, as every pool has a fee it's initialized with. But this, as Xin mentioned, is customizable now. And it's customizable in a few ways. You can, 1, change it to be any fee tier, so you're not condensed to only have one of 4 potential fee tiers. And 2, it can be dynamic. And when a fee is set to be dynamic, we actually have a specific number that this is going to show. And yeah, it's a little strange. It does make sense. It's essentially the decimal conversion of this 0x8 and a bunch of zeros. But yeah, just wanted to flag that it will look a little different. And so now we're going to kind of get into the meat of it, which is hooks. And I think hooks are the big differentiator in V4. So this is an example of a hook swap flow. And maybe you've seen this before if you've read the V4 white paper. But essentially, I wanted to bring this up today to just kind of show you and remind people, like, how does a hook actually plug into the swap flow? So let's say a user starts a swap, right? This check before swap flag and check after swap flag are essentially two hook functions that could be either, that would basically be, in this case, in the same hook. So one fun thing with V4 is that there are a bunch of functions that we can do, which I'll get to next. But there's only one hook contract per pool. And so that's kind of something that we'll see later on. But yeah, essentially you start a swap. You can check before if something passes, doesn't pass, whatever criteria you have set. It'll execute that swap, do a bunch of things. It'll check after the swap, and then it'll end. And that's kind of what swap flow would look like with a hook that has two hook functions, this before swap and after swap flags. Ooh, okay. So as I said, there's 14 hook functions, and this bit will make sense after the next slide. And don't worry if you don't take all of this in. I kind of just wanted to show them all so you could kind of see the different places where a developer could eventually build a hook. Yeah, so there's 14 of them, and we're going to get into how we actually figure out what a given hook address, which hook they are plugging into, or which function. So this, I think, is a really cool feature in V4 because essentially we encode this data within the address of the hook itself. So the last 2 bytes of a hook will always tell you what flags the hook actually is built with. So if we go back one slide, now this makes a lot more sense. This is actually the flag mapping of those 14 bits in the last 2 bytes of an address, which I know is a lot of very technical information, but it is very cool when you can actually see, based off of this little example code in Dune, exactly what hook flags a specific hook address is using. And this can allow you to look at information, when we have a bunch of V4 pools, you can kind of understand pretty easily what hook flags are developers using, what seems to be the most popular, what area of the swap flow is a certain thing kind of tweaking, and what does that look like? And yeah, that's just a little bit about how it's encoded. I'm not going to get into how to convert hex to binary. That's how you do it in Dune. And yeah, I don't know if I was going to ask this bonus question on the fly, but I figured I'd just put the answer in there. You can work out how that's done if you're interested. But yeah, on to modify, liquidity, and swap. So I kind of put this slide in here to just hone in on the fact that, while the swap event looks similar for V3 and V4, the main difference is going to occur in this modify liquidity event. So previously we had, 3 events, mint, burn, and collect. We will now have only one event that's modify liquidity, and the way that you're going to differentiate between if it's a mint or a burn is dependent on the sign of the liquidity delta. And so if this is a mint, but if it was a burn, you would see that be actually negative or collect. All right, cool. So for this last little part, we're going to jump into everyone's favorite and least favorite metric, which is TVL, and talk about kind of the difference between calculating TVL with V3 versus V4, because I think this differentiation in the modify liquidity event is what impacts this the most. And so we're just going to do a quick refresher on how you calculate TVL for V3. So there's 3 steps, right? You have to calculate token balances, and you divide them by the correct decimals for whatever tokens you're looking at, and then you convert to USD, which all sounds simple. Essentially, we kind of mentioned it before with the signs, but this just shows you what signs each event will emit, and what you should how to basically sum up them. But yeah, I guess it should be, you know, Xin told me to mention this, but the swap event, though we say it's always opposite, if with Flash loans, you can actually have, if it's positive, both positive, that's technically a Flash loan, but we're not going to get into that today. This is how you would go and calculate TVL, and the TVL by pool graph that you saw earlier on in our slides is actually using this method, and we can link that query later. Warning, it might crash Dune's website, but it does work, and yeah, we can do it by token as well, which is a little bit easier. So yeah, now getting into calculating TVL on V4. So as we said, you know, we don't have this mint, burn, and collect. So one other thing that we actually don't have is amount 0 and amount 1. So in the mint, burn, and collect events, we typically, in V3, had the actual raw amounts of token 0 and token 1. And now we don't have that. So we actually have to go, and for each modify liquidity event, we have to calculate the amount 0 and the amount 1 for each of the tokens. And this involves some really fun V3 math, which, if you want to talk about, happy to talk about it after this. I will be sharing out a lot of resources on how to easily do this, as well as an example query if anyone's interested. But in order to keep this talk kind of more high level, we're not going to get into that today. Happy to discuss it with anyone, though, after this. But yeah, this is just like the main difference of how we would calculate TVL on V4. And yeah, stay tuned for us actually going through and doing that later on. And I don't mean later on today, I mean later on Twitter. All right, so the last little fun kind of shout out today is in prep for V4, we kind of worked with the Dune team like a few weeks ago and created these incredible multi-chain events tables. And so, you know, also the chart that you saw earlier around the feet or the volumes by version, not fee tier, that was created kind of with one of these tables. So these are going to make basically looking at like pools across multi-chains very easy to see. You can probably calculate TVL across chains a lot easier with this. And yeah, we're super excited to have these for V4 as well when V4 launches. So just wanted to thank the Dune team and let everyone know that their lives are a little bit easier now that all of Uniswap version events are all combined. Yeah, so Uniswap, it's really good. Nothing I know is better than Uniswap. Just trust me, bro. Just use Uniswap. And that is exactly how we're going to end this. So, yeah, we have 10 minutes for questions now. If anyone has any questions on V4, another exciting topic which you may know about is Unichain. But yeah, if you have any questions about Uniswap, happy to take them now.
Does this work? Okay, perfect. Cool, thanks guys for the talk. For someone that has not followed the transition to V4, could you explain why you're switching to having one event as opposed to multiple events? I mean, you explain how to get the data, but what's the reasoning behind it?
Yeah, I can take this one. So part of it was like the way, so, well, one, gas costs. It does save a lot of money, and one of the big props of V4 is that it's actually like 99% cheaper to create a pool, and so we wanted to make the user experience even cheaper in every way that we possibly can. So that was one reason, and I think another reason is just because of the way that Singleton is structured. Like the pool manager contract itself, it's a lot easier to just have this one particular event. And yeah, I think those are kind of the main two reasons. I think the smart contract developers probably have a more in-depth answer for you there. But those were the answers that I was given, so.
Cool, thanks.
Yeah.
Not far. What are the V4 hooks use cases you are the most excited about?
Okay, should I go? I'll say one thing that's general and one thing that's maybe specific. Starting with the specific one. So a lot of people are building sort of MEV capturing or resistant hooks where they either have some sort of dynamic fee structure, or they have an auction, or some mechanism where they try to, instead of having the bid to arbitrage against the pool go to some validator or sequencer of the chain, they're trying to redirect it to the LPs. So that is a big direction that's being explored right now. I think there's also mechanisms being proposed to enable sort of real-world asset on chain. I think Gordon and his team at Circle has done like a hackathon organized by the Uniswap Foundation, where they proposed a way to bring kind of real-world assets on chain through hooks. And I think those are kind of a very exciting market segment. But I think in general, one thing I want to say is the reason we design things with a hook structure is we don't have a strong opinion as to what hooks will be good. So we want to enable sort of maximum competition, and then what comes out as the winner will be selected as the winning hooks, and we will naturally be excited about those ones.
Grace, do you want to add something?
Sure. I would say one hook that I'm kind of excited about, because I think it'll be, I don't know, I think it's kind of funny that we could do this, is essentially we could build V2 with V4, where you have the same type of pools where you don't have concentrated liquidity, but since V2 still is very popular on a lot of chains, because it's simple to use and understand for LPs, we could do that through V4 and make it so much cheaper for people to actually be able to deploy these V2 pools, which I think opens up just like kind of a world of possibilities of what people could actually launch. Yeah.
That's quite an unusual use case.
I know. It's kind of doing something that we've already done, but making it better, using the new things that we built. So that's why I kind of like it. But yeah, I'm also just excited to see, part of the reason I put in a bunch of stuff about hooks is just kind of understanding where developers are leaning. Like, what part of the swap flow do people actually want to iterate on? And like, where are people finding, what hooks are the most popular, like Xin said, but also like, where are people finding that they could customize the swap flow to improve the user experience or the LP experience throughout the swaps. So, yeah.
Thank you.
Hello. My question is, what's the relation with V4 with cross-chain intents?
Xin, do you want to take this one?
Sure. I think it's actually somewhat orthogonal. I don't think V4 was designed in particular with cross-chain in mind. I do think V4 adds complexity to routing even within a single chain. And so I guess routing across chains will be even more challenging. So I think the interaction, I guess, adds complexity to routing. But I don't really have a take on how V4 maybe enhances routing across chains. So
Yeah. I have nothing to add there. I would agree. Thanks.
Hey guys, how you guys position V4 compared to V2 and V3? Because like V2 is easy to manage, understand liquidity. V3 is more of like capital efficiency. And do you foresee like V4 is going to be replace those markets or is extension? And another question is V4 going to be live with Unichain at the same time?
Sure. Okay, so I'm going to answer this with the first question first, which is how do we differentiate, or how do we think about the differentiation of V4 with comparison to V2 and V3? I think you would need, like, in terms of what types of pools would launch. I think the way that we our mental framework for this is V4 still has the same, concentrated liquidity model that V3 has. And it is so customizable that you could build potentially V2 where you don't have concentrated liquidity on V4. That being said, one of the features of V4 is that it's like a very unopinionated protocol in the sense that we make very few decisions, and hook developers and those that deploy, pools with hooks kind of get to decide how they really want to customize and tweak that specific pool. So we it's almost like it is an extension of V3, but at the same time, it's like such a different or such a larger TAM that we're kind of excited to see what people actually build with V4 and kind of how the market takes V4 and what their differentiation of V4 actually is. And then in terms of timelines, it's kind of up in the air right now, but we did just, as Xin said, we did just announce the V4 address mining competition. So we won't launch V4 before we have an address for it. So that's pretty much all I can say there. And yeah.
All right. Thanks, everyone.